Hello, my name is Ike Kiefer. I purchased a OneWheel Plus in January of 2019. I've loved every minute of riding it. I have about 1,400 miles on it now, but when I hit 1,200 miles, just after the expiration of my 1-year warranty, unfortunately, I started to hear an organ grinder type sound and correctly deduced from help from the online forums that it was a bearing failure. And I also learned from the online community what to do about it, and have successfully replaced my bearings now and restored my OneWheel to good operation. But in the process, I learned some things about the assembly and design of the OneWheel that I want to share with the community, because I think there's some factors that actually contributed toward the bearing failure and that need to be addressed. This information I previously shared with OneWheel directly, and pretty much got the answer that everything's fine. So I told them that I wanted to share it more broadly so that the community might be able to assess for themselves what risks they're taking and what they might be looking for in their own OneWheels. I do not know if this is a problem with the XR or the Pint. But I suspect that for the XR it probably is the same. It's probably the same motor and such, but I would love to get some feedback from other owners who may take the same steps and do the same measurements that I've done here. So without further ado, when I disassembled my OneWheel, I found that the bearings were off-brand from China C&U. This is the bearing number, and RS has to do with how it's sealed. There are replacement bearings that people propose. Some of them have an RZ instead of an RS suffix. That has to do with how it's sealed. I think either of those are good choices. As far as manufacturers, SKF is commonly recognized as a superior bearing, and Burris as well. SKF had a nice graphic that I chose to borrow for this. What I've seen in the difference is the cage part here that holds the roller bearings in place is metal and SKF, and the ceramic hybrid ones that I chose to use from Burris have a ceramic ring that holds the bearings. But I think either of those are excellent choices in bearings. Just for dimensions, the shaft of the OneWheel is 35 millimeters, and then the bearing itself has an outer diameter of 55, and the cross section here of the race area is 10 millimeters by 10 millimeters. So that's just to get you acquainted with it. This is as if you sliced a bearing in half, and you can see the race and the bearing, the ball bearing itself. This is the shaft itself, 35 millimeter diameter. That's the 10 millimeter width seat that the bearing sits on. And then a very important dimension is this shoulder area called the abutment, and that's what actually stabilizes the bearing. And it's especially important that it has a certain minimum height, because there's a chamfered edge to the bearing down here. So if this wall is too low, you have very little actual contact to stabilize the bearing in place. Same thing up here. So the SKF bearing manufacturer recommends a minimum 38.2 millimeter diameter, which equates to a 1.6 millimeter abutment height or shoulder height here. And we'll see that that is an issue with the manufacturer of the OneWheel Plus. Here you can see photos of the motor upon disassembly. This is the shaft of the closed end of the motor, and what's obvious here is that there is a silicone O-ring that sits in a groove underneath the bearing seat, and it's designed to keep particles from migrating in under the bearing and into the motor. Unfortunately, that O-ring is actually doing more damage than good, because it was destroyed upon assembly at the factory. And this turns out to be a frequent discovery when other OneWheel owners have disassembled their motors, is they find that their O-rings were also shredded during assembly at the factory. This is a problem for several reasons. One is you can see that fragments of that shredded O-ring end up inside the motor, and even worse than that, the bottom photo shows that fragments of that O-ring end up wedged between the bearing and the abutment wall, which means that you do not have a square seated bearing with metal to metal contact. You have a bearing that's been cocked in its race, in its seat, because of that obstructing material, which is terrible thing when you consider that microns of misalignment matter a great deal to the life of bearings. This has also turned out to be the case on the other end of the motor, on the open end shaft, where I had identical damage. So I was 0 for 2 in that both of my silicone O-rings were shredded at the factory during assembly. Upon disassembly, I decided to spec out the O-ring itself. I used a bearing press kit to determine that the inner diameter of the silicone O-ring was 33 millimeters and that its cross section was 0.6 millimeters. As I'll show in the next slide, that 33 millimeter inner diameter O-ring is sitting in a 34 millimeter diameter groove, which means there's very little elastic tension holding it in place, and that is likely one reason why it is so subject to being caught by the bearing when it's being pressed in place and shredded. And so when I chose to rebuild my OneWheel, one school of thought out there was to use Teflon tape and kind of construct your own O-ring. I didn't like that for several reasons. One is it's very imprecise, and another is Teflon is a lubricant, and did not really want something that's a lubricant between my bearing and the seat. You really do want some friction there. So I decided to follow the advice of another forum member who had tried 22 millimeter O-rings, I did some math to confirm that that is the right size. If you take a 22 millimeter O-ring with a 1 millimeter cross-sectional diameter and you stretch it to 34 millimeter diameter groove, then you're going to reduce its cross-section to about 0.6 millimeters, which is what you want. You want something that's going to just sit up barely above the 0.5 millimeter groove depth, and so it'll make contact with the bottom of the bearing but not stick up enough that it's going to get caught during assembly and get torn. So I purchased, I also decided to change materials from silicone to nitrile rubber, which is a much stronger material, and I had good results in my assembly, and I bought a pack of them off of Amazon. 20 pack was less than $6 total cost. So I would recommend that people actually do put a proper O-ring in and not do the Teflon tape job, but to each his own. Here's a better picture of what we're talking about. You've got the motor and the windings here. This is that abutment, that shoulder. This is the 10 millimeter seat that the bearing sits in, and halfway across that is a 1 millimeter wide by 1/2 millimeter deep groove where that O-ring sits right in here. And you want the O-ring to be at least a 0.6 millimeter so that it's up enough that it's going to produce a seal with the bottom of the bearing, but you don't want it so high that it gets caught when the bearing is pressed and gets torn and pushed up against here and blocks the bearing being seated against the abutment. You can also see that this abutment is not very high, and we'll see specifically a problem with that in a future slide here. I spec'd it out, and I got a 37.8 millimeter diameter for the abutment end of things. You can see that 38.2 is the minimum that SKF recommends, the manufacturer of the better bearings, and the maximum is 41.5 millimeters. When you look at that, I'll have a diagram here shortly, but basically what we saw again was that the minimum should be a 1.6, but we actually have a 1.4 millimeter abutment manufactured in the OneWheel Plus. And that's really a problem, again, because the bottom end of this bearing is chamfered, so you have very little flat surface-to-surface contact on this bearing, and I'll show you that picture next. This is an actual 2-scale cross-section of the shaft here. So this is the abutment side of the shaft. This is the 10 millimeter wide seat for the bearing. This is the 0.5 millimeter by millimeter groove for the O-ring. And then the actual shaft is a little bit even skinnier on the outer end. But this is pretty much what I had when I disassembled it. I had the silicone O-ring was kind of jammed in. It must have been caught in assembly and peeled across underneath the bearing and wedged between the bearing and the abutment. And then I had loose fragments actually inside the motor end. And if you look at this closely, I've kind of depicted it as if the bearing is just slightly twisted in its position, which to some degree it is. I mean, it's going to be fractions of a millimeter, but that matters a lot in the life of a bearing, where microns matter, not just millimeters. So there's the damaged O-ring not properly seated in the groove. There's the fragments of the O-ring inside the motor cavity, and then the abutment height. Here in green, this is the manufacturer's suggested abutment height. The minimum is the bottom of the green and the maximum is the top of the green. So this red area shows that it doesn't even meet the minimum height, and you'd really like to see something up in here. I don't think there's any reason why you wouldn't want to have an abutment height well into the green. And this shows the proper positioning of the O-ring in the groove, where it's making good contact vertically, but you have a little bit of room horizontally for it, so it's not getting pinched or scraped out. And this shows the bearing, nicely squarely seated on the shaft. All right, another problem I found, which surprised me, was when I took the housing of the motor off and took a look at it. This is not dirt. This is paint. This is paint that migrated from the outside. I don't think it migrated. I mean, it was overspray that from painting the outside, it wasn't properly cleaned. So this is the abutment for the bearing on the housing side. And I'll show another picture here from the inside. You can see these little bumps. That's paint areas where it's overlapped on the inside. So again, you're not getting a clean metal to metal seating of the bearing on the hub because of this paint overspray. And so before I reassembled my OneWheel, I went in there and did some careful scraping and removed that overspray to get a better seating. So in summary, insufficient bearing abutment height, which is non-trivial, and that's a basic engineering design issue, or manufacturing error, and that's something that can only be fixed by replacement. The Chinese bearings, again, they could choose a higher quality bearing, and at least a recognizable name brand that has a reputation. The O-rings, again, I think that's a significant issue, and that's an easy fix. And then the paint overspray, again, that's just a manufacturing procedural thing, a quality control thing that could have easily been taken care of and should be in the future. So my recommendations for Future Motion, to correct the design and manufacturing issues, particularly the abutment. In future manufacturing, that abutment height should certainly be within the manufacturer's specs. And I think they should replace their silicone O-rings with ones that don't have the shredding problem. For us who have experienced the failures already, you could argue that if it made the 1-year warranty, then that's good enough. I personally would like to see them as a good faith effort, and also recognizing that there actually is a design defect that's out of spec for the bearings, that they could compensate current owners with perhaps one free factory bearing replacement, and limit that to something reasonable, like say 2,000 miles of ride distance on the odometer. For us who want to do it ourselves, they could maybe provide a do-it-yourself kit for bearing replacement, so that we don't have to send it into the factory and wait on the timelines that entails.